Something hiding inside our own galaxy has apparently been misidentified for over 50 years, and the James Webb Space Telescope just quietly changed everything we thought we knew about how the Milky Way was built. If that sounds like the kind of thing you want to keep up with, hit subscribe right now, because we cover discoveries just like this every single day. For decades, astronomers believed that an object known as Tarzan 5, captured many times by telescopes including Hubble, was simply a standard globular cluster, just a little dustier than most. And to understand why that label mattered, we need to briefly explain what globular clusters actually are. These are ancient, densely packed balls of stars. They typically hold hundreds of thousands, sometimes even millions of stars, all bunched together in a relatively tight formation. In some descriptions, people refer to them as stars made out of stars. In most cases, they are some of the oldest objects in the known universe, usually somewhere between 10 and 13 billion years old, because the majority of them apparently formed around that period in cosmic history. Now, there is still something of a mystery surrounding exactly how they were created and what conditions triggered their formation in the first place. But because most galaxies seem to contain them, they have become something like a natural laboratory, a tool that scientists use to study how galaxies evolved, how stars change over time, and how the earliest galaxies first came together. That is partly because even in a distant galaxy, it is actually fairly straightforward to count how many globular clusters seem to exist there, and then use that count to work out various properties of the galaxy itself, including how many collisions it possibly experienced over its long history. More globular clusters generally seems to suggest more collisions. Traditionally, though, one of the core assumptions about globular clusters was that every star inside a given cluster was essentially a sibling, meaning all the stars formed at roughly the same time, most likely from the same collapsing gas cloud in a relatively short window. That was the standard picture. Tarzan 5, however, was located inside the galactic bulge, the dense spherical central region of the Milky Way packed with ancient stars, making it an unusually difficult place to study. It contains a great deal of gas and dust. The object is so hard to observe that it was only identified in 1968 by French astronomer Auguste Tarzan, which is why it carries his name, and from that point up until very recently, Tarzan 5 was simply classified as a globular cluster, dusty and unremarkable. But things started becoming unusual fairly early on. Back in 2009, scientists studying Tarzan 5 discovered that it does not seem to follow the standard rules for globular clusters. Specifically, they found that it appears to contain two separate generations of stars. One group was approximately 12 billion years old, while another group was only around 5 billion years old, implying a gap of at least 7 billion years between their formation events. That alone was already quite difficult to explain. Then came the new observations from the James Webb Space Telescope, analyzed in a recent study led by Zuo and the team. Using infrared data, the researchers measured what is called the proper motion of stars, essentially tracking how individual stars move over time. By carefully separating the stars that belong to Tarzan 5 from the background stars and comparing their movements, the team was able to identify something quite unexpected. Tarzan 5 apparently does not contain just two generations of stars. It seems to contain four distinct generations. Stars appear to have formed there approximately 12.5 billion years ago, then again at around 4.7 billion years ago, then at 3.8 billion years ago, and finally at roughly 2.5 billion years ago. That pattern does not fit the profile of a globular cluster at all. It fits something different, something that astronomers are now calling a bulge fossil fragment. Essentially, this seems to be a new category of object. The thinking goes like this. Billions of years ago, the central bulge of the Milky Way was forming as massive clumps of stars merged together. Tarzan 5 was possibly one of those clumps, a primordial building block that was originally on track to merge into the bulge itself. But for some reason, it survived. It was not destroyed over billions of years, most likely because it was just massive enough to maintain its own structure. It apparently held around 2 million solar masses, which was seemingly sufficient for it to retain gas and hold on to its early stars. That trapped gas allowed it to behave almost like a miniature ecosystem, cycling through four separate star-forming episodes over several billion years. As new stars were born from the gas, it continued to capture during the bulge's formation. So rather than a simple ancient ball of identical siblings, Tarzan 5 seems to be a surviving relic, a fragment that somehow outlasted the very process that built the galaxy around it. This discovery appears to matter quite a lot. and for several interconnected reasons. First, it dramatically changes the way we think about certain globular clusters, or at least the objects we have been calling globular clusters. At least some of them may not be true globular clusters at all. They may instead be survivors from a much more chaotic and clumpy early universe, and that distinction is meaningful. The finding also confirms something that astronomers have been trying to piece together for some time, that galaxies like our own Milky Way very likely formed through the merging of many smaller, clumpy structures over cosmic time. Interestingly, the James Webb Space Telescope has already found quite a few such clumpy structures in the very early universe, billions of years in the past. One well-known example is an object called the Firefly Sparkle Galaxy. What Terzan 5 now offers, apparently, is a surviving version of one of those ancient building blocks right here inside our own galaxy, accessible, observable, and available for study without needing to peer billions of light years away. That is a remarkable thing, and Terzan 5 possibly does not stand alone in this. Another object, Belvoir 1, has recently been identified as a possible bulge fossil fragment as well, because it also seems to contain multiple generations of stars, suggesting that these kinds of survivors may not be entirely rare. Meanwhile, other globular clusters continue to reveal their own puzzles. The cluster 47 Tucanae, for instance, was found to emit a mysterious radio signal from its center, and nobody currently seems to know what is producing it. It could possibly be some kind of unusual pulsar, or perhaps a rare intermediate mass black hole, but right now the source remains unknown. Other clusters have been found to contain anomalous chemical abundances in certain stellar populations, hinting that multiple star-forming episodes may have occurred in more clusters than previously assumed, and a cluster called VVVCLOO2 seems to be on an unusual and extreme orbit, apparently plunging toward the center of the Milky Way at around 400 kilometers per second. It is possibly coming from somewhere else entirely, and may eventually be torn apart by tidal forces near the central black hole. Where exactly it originated is currently unknown. The broader picture that emerges from all of this is that globular clusters have been puzzling objects since their initial discovery in the 17th century. Unlike galaxies, they show no clear signs of dark matter. They tend to exhibit striking uniformity in the chemical composition of their stars. We do not fully understand how they formed or why they end up so spherical. Supercomputer simulations using a project called EDGE, short for Evolution of Diverse Galaxies and Environments, have even suggested that a new category of object may exist, sometimes called globular cluster-like dwarfs. These would be objects that look like globular clusters on the surface, but seemingly contain a halo of dark matter around them. No confirmed real-world example of these has been found yet, though there is one candidate, a small dwarf galaxy called Reticulum 2, that resembles a globular cluster and also appears to contain its own dark matter. Finding more such objects in the real universe could potentially open a path toward understanding what dark matter actually is, and perhaps identifying the particle responsible. All of this combined points in one direction. Globular clusters are far more dynamic, far more complex, and far more varied than we once assumed. What once seemed like simple ancient leftovers now appear to be layered, evolving systems that sometimes contain black holes, possibly contain dark matter, and apparently retain memories of the very earliest moments of galactic formation. Even as of 2026, how most of them originally formed remains genuinely unclear. So this is where things stand, with Terzan 5 quietly sitting in the center of our galaxy, no longer a dusty, unremarkable cluster, but apparently a fossil from the very process that built the Milky Way itself. The researchers from the University of Bologna are now planning to study roughly 50 more globular clusters to see whether additional fossil fragments might be hidden among them. Every answer seems to open new questions, and the galaxy we thought we understood keeps turning out to be stranger and more layered than the older textbooks ever suggested. We will come back to this topic as new findings emerge.